Hi everyone, this video is on the mixed exercise 12 question 16. So we have this equation and we want to find the value of x and the value of y when divided by the x is equal to 0. Okay, so we first need to find divide by the x and then we set that equal to 0 to find the x value. And by having the x value, we can substitute that into this equation to get the value of y. So before differentiating, let's rewrite the equation in a form that can be differentiated. So we need to rewrite this in the form x to the power of n, y is equal to x to the power of n. So y is equal to x to the power of 3 over 2 plus 48 times x to the power of minus 1. Now let's differentiate this equation. So we have divided by the x, and that is equal to 3 over 2 x to the power of a half minus 48 x to the power of minus 2. Okay, now let's set divide by dx equal to 0 to find the x value. So we are basically finding the stationary point of this curve without being told directly. So we have 3 over 2 x to the power of half, and then we can rearrange the equations to get 48 over x squared. Then let's do a cross multiplication. So I'm going to multiply both sides by x to the power of 2. So that's going to give us 3 over 2 x to the power of 3 over 2. And, sorry, not 3 over 2. It's 5 over 2. Because 2 plus a half is 5 over 2. Is equal to 48. And at this point, we can multiply both sides by 2 over 3. So we are going to have x to the power of 5 over 2 is equal to 48 times 2 over 3. And 48 times 2 over 3 is 16. So we have x to the power of 5 over 2 is equal to 16. I'm sorry, here 48 divided by 3 is 16, and then times by 2 is 32. So this is equal to 32. Okay, now we can then use my calculator maybe to find the value of x. That's one way. We can also simplify this, but let's just use calculator to find this value. So just as a quick reminder, x to the power of 5 over 2 is equal to the root x to the power of 5. So that is equal to 32. So in this case, basically what we need to do is that we first need to square both sides. So we have x to the power of 5 is equal to 32 squared. And then we can take the fifth root of both sides to get x is equal to the fifth root of 32 squared. And that gives us 4. So x is equal to 4. There was actually a simpler way. As I said, we could have simplified this. So one other approach could be rewriting 32 as 2 to the power of 5, and then we have this power of 2 outside. So we have then x to the power of 5 is equal to 2 to the power of 10. And then one approach could be sort of guessing here, because here if x is 2 squared, then that's basically going to be 2 to the power of 10. Yeah, and we could have used logs as well. So as you can see, there are many variations here, but anyway, x is equal to 4. So now that we have the value of x, we just substitute this into the equation of the main equation, which is y. And when x is equal to 4, then the value of y is simply equal to 20. So this is basically the stationary point of this equation. So the stationary point has coordinates 4 and 20. So that's the stationary point. And then in part B, we want to show that the value of y, which we found in part A, is a minimum. So in order to show that a value is a minimum, we first need to find a second derivative, And by having the second derivative and substituting x into the second derivative, based on the sign of the second derivative we get after substitution, we can then determine if that value of y is a minimum or a maximum. Because if it's positive, if the second derivative is positive, then it's a minimum, and then if it's negative, it's a maximum. So for part B, we first find d squared y by dx squared. So we can differentiate this expression here, this equation. So we first have half times 3 over 2, which is 3 over 4, x to the power of minus a half. Then we times minus 2 by minus 48, and that's equal to 96. And then this minus 2 will become minus 3 when differentiated. So we have 96x to the power of minus 3. So this is the second derivative. And at this point, we just need to substitute x is equal to 4 into the second derivative and see what is the sign of the second derivative. So when x is equal to 5, then the second derivative, which is d squared y by dx squared, is equal to 15 over 8. And that's positive, right? So since the second derivative is positive, we can conclude that this curve has a minimum. So that's very important. Again, it's just because of the sign of the second derivative, and that determines the nature of the curve and the stationary point. Okay, that's it for this video, and thank you for watching.